So every single one of these functions in this table is an exponential, and all of them have an asymptote. So here we have an exponential, okay? The 3 to the x part is the exponential part, and this plus 3 is your asymptote. Y equals 3. Okay, that means that on this one, the asymptote is at 1. For here, the asymptote is at 5, and on this one, it's at -3. Okay. It's also pretty easy to tell on the graph. If you notice, your graph started up here, and it's decaying, and all of a sudden it starts to flatten out. So this flat part, okay, that's your asymptote. So this has one at 1. Okay. The hardest part is to do it from a table, and it's kind of have to see this pattern. If I take 8, take half of it, I get 4. Half of that is 2, half of 2 is 1. If I continue to take half, then I'm going to see this pattern continue. If I continue to take half of these values, they're going to get smaller and smaller and smaller, but they're going to get closer and closer to the value of 0. Okay, so it says mark any of the exponential functions that have the same asymptote. That would be this function here and function k. All right, moving on to number 3. Which of the following results in the largest values as x approaches positive infinity? So the big idea here is to understand that exponential grow faster than anything else. Okay, so let me write this down. All right, there we go. Exponential will eventually grow faster than both linear and quadratic. So of these that are here, I know that function e is linear and function d is quadratic because of the x squared. Okay, the remaining ones all have 3 to the x, 2.2 to the x, 2 to the x, and 6 to the x. All of those are exponential. The one that has the largest base is function t over here because of this 6. Okay, it has the largest base. So that means that it's going to be the one that eventually grows the fastest. Okay, the other bases were 2, 2.2, and 3. So that's why I chose that function. All right, down here, Aaron is supposed to be creating the sequence given by the formula 6 times 3 to the n minus 1. She incorrectly began writing the sequence 2, 6, 18, 54. Explain what her mistake is, what the first 4 terms should be, write the recursive formula, and then find the difference between the 8th and 10th term. Okay, I think we can do that. So the first term, if I use my calculator's table, I would need to put in 6 times 3 to the x minus 1 power. The first term is actually going to be when I plug in a 1. So if I do that, that's 1 minus 1 is 0. 6 times 3 to the 0 power is 6. The first term should have been 6. Then I'm going to see this pattern where I start to multiply by 3. So 18, 54, and then 162. Those are the first 4 terms. Okay. The recursive formula would be to find any term, I multiply by 3, and my first term is 6.